So displacement maps we know are covered in Tool Displacement Map. Okay, and let me just restart this. I'm going to go into a simple project. And I am going to import a tool or load a tool. Now, looks like I'm going to have to import an OBJ. This little device, simple polygon model, is what I have seen companies use to kind of calibrate displacement maps. What we do is we divide this and we put a little bump that touches the top, a bump that touches, and a bump that touches. And then we use this to kind of help us understand what our settings need to be inside of Maya Mental Ray to kind of get the accurate readings. So let me see, I think I'm going to load a project actually that has this already sculpted. Okay. Let's turn displacement off. So here's the model. I turned SMT off. I divided twice. I turned SMT back on. Here's the sculpt. It's real simple. It's just a move brush. Press Alt until you get close, and that's it. Okay, the UVs were created using UV map, UV master, and it's real basic. And all I did was just go to the lowest subdivision level and go to UV master, and I just clicked unwrap. There was absolutely nothing else or anything special that I did to it. Okay, now once that part was done, and I've got this sculpting, I'm going to drop it down to the lowest subdivision level. I'm going to go to displacement map. I'm going to turn adaptive on. And for Maya, I'm going to turn flip V on. I'm going to show you, if you don't turn that on, how you do it. But I'm going to show that to you later. And then click create displacement map. All right. So there's our displacement map. And here's a really important setting, 1.2. But that's our displacement map. So we're going to export it. We press clone. It shows up over here. We select it and we export it. Okay, I've already exported it, so I'm just going to cancel that. And then you probably want to export the low res. So you've got your model here. We're going to just export that, and let's just call that 12. And there we go. So I've got a little sculpt, I've got a displacement map, and I've got UVs, and I'm ready to get this over into Maya to kind of test things out. But before I do that, I want to unpack a little bit about displacement maps and just kind of help you understand what these settings are. So there are two types of displacement maps. One of them is called adaptive, and the other one is called not adaptive, which means adaptive is not on. The technical term, let's see, one was adaptive and the other one was, it's been so long I've forgotten, especially now that they've taken the name out. They take the name out, the memory goes with it. Anyways, DP subpix is only relevant if you're not using adaptive. Let me explain what adaptive does. So and let me just explain what a displacement map does. So I'm going to, in a green line, I'm going to create a base mesh. In a red line, I'm going to create some sculpt. So here I'm going to have a lot of bumps. Here we're going to have a nice gradual arc, and then suddenly crazy things starts happening and gets really crazy and then straightens out. If you do not have adaptive on, well, actually before I get there, the way displacement maps work is that they'll take each one of these faces and each one of these vertices. In fact, let's say it this way. In terms of a bare bones representation, what a displacement map does is it calculates out a ray from a vertice and says, hey, you are X units away from me. And that space, that amount of distance, is represented in terms of a grayscale value. So let's say this calculates out and it says, hey, you are, let's say, 2 centimeters away from me, and then ZBrush has its, its own calculation. Let's say 2 centimeters equals something that is, let's say, 60% white. Then you get your displacement map at 60% white. All right, out here it looks like this is maybe 4 centimeters. So maybe 4 centimeters equals 80% white. And so that's where you get these little white dots in there. Of course, what's the problem with this vertice method? I mean, you can see it right now. If all I'm doing is shooting out rays from these vertices, well, I'm missing all of this information. I totally miss this bump right here. None of this stuff gets captured because, it's only got this one vertice that it's shooting out from. So what ZBrush does instead is it will take this, let's do this color in blue. It'll take this green low polygon model, and then it creates what's technically called a limit surface. Limit surface. A limit surface is a subdivided surface that imitates what this model would look like if it was subdivided in a normal Catmull-Clark algorithm. And this subdivided surface will have multiple vertices in there. Just like when you subdivide geometry, you get lots more vertices. Lots more vertices mean you have a lot more rays casting out and calibrating how much distance there is. So you'd have a lot more rays catching all of this information. Does that make sense? The blue line is a limit surface. The green line is that actual low res. The white lines are rays that are casting out to the final surface, which is the red line, and giving us a grayscale value. It's complicated. I'm not going to lie. I mean, I was explaining this a long time ago, and the only reason it's still in my head is because I had to explain it to people for years. So if you don't get this, if it doesn't stick, don't worry. You've got the recording. Keep it around. Make a little note of where that is. Now, the reason why I'm telling you this is if you're not using adaptive, then ZBrush is going to use DP sub pix. What is DP sub pix? DP sub pix is basically, in the simplest terms possible, it is the geometry resolution slider for your limit surface. Basically, if I set this DP sub pix to 2, then it's going to divide the it's going to divide this limit surface by, let's say first it divides it twice, and then it divides it again. So if I set DP sub pix to 2, then it's going to divide it 4 times. If I set it to 3, then that all gets quite a lot more intense, right? And so if you set that DP sub pix to 6, well, now you can imagine you've got a ton of vertices shooting out and taking up an enormous amount of time as they calculate the displacement map. And some of that is waste. Some of that is totally unnecessary. It is a brute force approach. So turning adaptive off and using a DP sub pix of 4 is a brute force approach to solving the problem, which means that the entire surface, everything gets divided equally, And it all takes like an hour to render a displacement maps. A lot of time to render. If you use adaptive, then you basically tell ZBrush, hey, I need you to run interference for me. I need you to look at those parts of the model that are more complex than the rest, and you're going to divide those guys more. So I'm going to undo this drawing a little bit, and I'll give you a kind of an approximation of what it would really do. Remember, the limit surface is subdivided, so it's already really kind of smooth. But basically what we're going to be doing is in these areas where it encounters a lot of movement, in those areas it's going to divide it a lot. But in those areas where it's not encountering any major movement, it's not going to divide it a lot. And here, you know, it's going to go crazy right in that area. So it's going to divide those areas, and that means that it's going to have fewer total rays being cast out, because here you're getting a lot of rays. Here you're only getting a few rays, not a lot. More, less, more. That's going to make it a lot faster, exponentially faster, when you consider how much of your model is most likely to be smooth or smoother or not need to be subdivided. So that's the biggest difference between adaptive and DP subpix. DP subpix is brute force, adaptive is intelligent. Adaptive breaks down on thin objects. That's just the nature of the business. If it's a thin object like a sword or something, then adaptive does not get the edge accurately. There are problems with it. Okay? Any questions about that? That's a lesson in displacement maps and how that technology works. It's very similar to how normal maps work. They're all kind of the same thing. All right, Ryan asks, rays must be in line of sight for the projection. Overlaps won't work. And yes, as Ed mentioned, vector displacement is a totally different beast for that. We're not going to cover that because that's it's supported, you know, by different apps. It's very cutting edge. But vector displacement is the way of the future there. And Johannes, would this make the adaptive method more or less accurate? Johannes, the accuracy of adaptive would be relative to how intelligent ZBrush is subdividing the model. So, if you were to ask the programmers, does that affect the accuracy, they would say, no, it's a very intelligent algorithm. They would not allow you to question that. And you could almost say, you know, the brute force approach, while it might be more accurate, is just really not intelligent and is very wasteful of your time. Aaron, what is flip V for? Well, as you can imagine, ZBrush thinks about the world differently, and one of those is that it creates your texture maps, displacement maps, alpha maps. It creates them upside down from how you see them and how Maya treats them. Some legacy on this. I don't know if this changed in Max, but basically ZBrush sees things the way Max used to see things, if I remember correctly. Max used to flip in V. I don't know if it still does. Flip relative to Maya. Or as Kathleen says, to everyone else.